Hello everyone, welcome to my talk about automating MariaDB deployments with Ansible. My name is Federico, I'm founder of Vettabase. We do database consulting, and I myself a long-time consultant and supporter and passionate of MariaDB and MySQL. This talk is not an Ansible tutorial, is more a collection of good practices and subtopics related to administration of MariaDB servers with Ansible, and probably they're useful also if you administer different databases, something different than MariaDB. What you will see here in this talk is based on my experience and opinions, but actually every case is different, and feel free to use some of the advice and not others, because maybe they're not good for you. And if you think I'm wrong on something, feel free to start a constructive discussion with me. But keep in mind that I'm always right. Of course, I'm kidding. So let's start with some general discussion on using Ansible the right way. So what is Ansible? Well, Ansible is a tool for automation of deployments and configuration. So it means it's surely useful for big deployments, but not only for big deployments, because even small deployments sometimes would benefit from good automation. It follows the infrastructure as code philosophy. So this means that we describe all our infrastructure as code, and then we can version it with Git or something similar. It's idempotent, which is very important because it means that we can describe a certain server as code, then we can deploy, and then we can change something in this code. For example, we can change just some software version and then deploy again. And many tasks don't need to be redeployed because they were already applied once. So this will not happen, and basically we can confidently redeploy a certain playbook against production servers. Also, it's simple, generally simple for most use cases, and it's not centralized, but more on this later. So where should we use Ansible? For example, we can use it to manage both production and staging. Okay, so we have a collection of roles, and those roles apply to both production and staging. We will have different inventories, so different lists of servers, more on this later, and different variables, and the variables handle the differences between what we have in staging and what we have in production. We can use it even if we have multiple microservices. Actually, it's very useful in this case. So we can have, for example, the same collection of roles for all the microservices. At least in many cases we can, and then we will have different variables to handle the differences between different microservices. And then we can also use Ansible to deploy our development machines, meaning the environments that developers use to write their code. And for example, in this case, something we can do is to use Vagrant to create those machines. They could be local virtual machines, local containers, or even remote machines. And then we use Ansible as a provisioner to install what needs to be installed on those machines. So as I said, Ansible is not centralized by nature. So many teams use it, in a very decentralized way. So a DevOps teams could allow all the team members to deploy from their own laptops. But actually, it's also possible to install Ansible on a centralized host, or maybe more than one for redundancy, and then only allow DevOps to connect to these hosts and then deploy from there. And then we could have some wrapper scripts to do some things like avoid concurrent deployments. So for example, two persons cannot deploy to the same machine at the same time. Log the calls to Ansible. Also, we can avoid to set up individual accesses, individual personal accesses to all machines. We can set up them for Ansible hosts only, for simplicity. And actually there are software that we can use to have a centralized Ansible. We could use Red Hat Ansible Tower, which is not free anyway, it has a cost. Or we could use also AWX, which is the upstream project of Ansible Tower. It's open source, but it's not really recommended in production for several reasons. So in most cases, what I recommend is just running Ansible on a centralized host and use some wrapper scripts if necessary. So let's talk about inventories. You can see an example here. In this example, I defined a PMM group with a single host. Why did I create a group if I have only one host? Well, because if my organization is not going to fail, it is supposed to grow over time. And then even if I have only one PMM server, I could have more than one in the future. So it's good to have already a group and to use proper name PMM-1. And then I have a MariaDB main group with 3 hosts, and then I define some variables. It's not really very common to define variables in an inventory, but there are cases it is better. For example, here I'm defining variables that are really related to the inventory, because they're supposed to tell MariaDB servers on which host PMM runs and which port is used. You can see here that, okay, maybe I don't have perfect host names, right? Maybe I cannot have a PMM host with PMM-1 as a host name. So I can actually use an IP in the inventory, but I still define PMM-1 as an alias. Okay. And here I show that we can have hierarchical groups. So for example, we can have MariaDB master and MariaDB replica. Each of them have different hosts. And then I specify that they both are children of MariaDB group. Okay, so MariaDB group will be used to define all the basic configuration and all the basic procedures that apply to all MariaDB servers. And then specific configuration for a master will be in a separate group, and specific configuration for replicas will be in another group. Here I want to show that we can have multiple inventories, and for example we can have one for each environment. So in this case we can have DB production and DB staging, and they actually have the same groups. This is useful assuming that production and staging are actually identical, right? So the inventories will have the same groups, the same host aliases, but they will actually point to different IPs. Okay. If we used microservices, we could probably use inventories like, I don't know, services DB production and services DB staging, or even service 1 DB production, service 1 DB staging, and so on. It really depends on your environment and how big your environment is. So let's talk about plays, which is strictly related topic. Here you can see that basically we use a play to assign hosts to certain roles, right? So here we assign 3 roles to MariaDB main, and roles are Linux for MySQL. It makes sense that it's a separate role because it can be useful for MariaDB, yes, but also for MySQL and for Percona server, so let's keep it separated. Then we have a dedicated role, of course, for MariaDB itself. And then we can have another role for MyDumper, for example, or any other tool. And the idea is, okay, in this case, we are assigning this role to all MariaDB hosts, but in theory, it's not necessary. Only some MariaDB hosts could have MyDumper, or maybe MyDumper could be installed on some hosts that don't run MariaDB at all. So again, it makes sense that the role is separated. And here you can see that basically we have only one play, which is main.yml, which can be used for the staging inventory or for production inventory. And this means that to deploy our changes to the servers, we have one command to use. Okay, the command is almost identical for staging and for production. The only difference is the -i parameter, which stands for inventory. Then let's talk a bit about roles and variables and templates and similar topics. And let's do it by starting with a common problem. The problem is, okay, suppose we have several MariaDB groups, and potentially each group could have different configuration. It's not uncommon at all. And actually, even each server could have different configuration. We should be totally free to do this, but we don't want to have a separate configuration file for each group or even for each host, because it would be unmaintainable. So a solution could be creating a minimal default configuration file used by all the hosts in all the groups. And then every group, or possibly even hosts, can define variables and the values of these variables are written into the configuration file. So to do this, we use a template. Okay, so Ansible uses templates with a format called Jinja2, which you can see here. And basically here you can see that there are some variables I've chosen to hard code. So in this case I hard coded user. It is the same for all MariaDB servers. But then I used variables for the paths. So for example, base dir, data dir, temp dir, and so on. And I will define, in this case, a default in the MariaDB role. But every group or event server is free to define a MySQL datadir variable which will override the default. Okay, so if I define it in multiple places, the group variable will override the default, and the host variable will override the group variable. Okay, so there is still a problem, because if I do it in this way, I will still have a file which is very big, because for each variable that is set, even if it's only set in one place, well, the variable will need to be written in the template. Okay, so this means that the template will bloat and will be very hard to maintain. Now here you can see another example where basically after the variables that I'm shown in the previous slides, I write two loops in the template. Two loops on two lists of dictionaries. Okay, if you use Python, you already understood what I mean, probably. We have two separate lists. One is called MySQL group variables, which is supposed to be defined at group level. And then we can have MySQL host variables, which could be defined for every host, but not necessarily, because as you can see, there is a check if MySQL host variables is defined, which basically avoids a failure in case the variable does not exist for a certain host. In any case, we will write, okay, for each item of this list, we will use an attribute called name and another attribute called value, and we will write name equal value. Okay, it's very possible that the same variable is present in the first part of the file, and maybe also in MySQL group variables, and maybe even in MySQL host variables. It doesn't matter, because a variable can appear multiple times, and the last time it appears will take effect. Okay, the previous occurrences will be ignored by MariaDB. So let's proceed, and let's talk about handling differences between machines, which is something very common. For example, if you have you know, smaller machines for staging and bigger machines for production. Okay, because production machines will be proper machines with an adequate number of CPU cores, amount of memory, maybe they will have good SSD devices, And maybe to save money in staging, you will have smaller machines which wouldn't be able to deal with production workload. But then our problem is part of MariaDB configuration could depend on the number of cores we have on the machines. Okay, and we don't want to keep it up to date to reflect all the differences between the various machines. So something we can do is, if you look at this example, we are using Ansible processor cores variable. Okay, it is basically a fact collected by Ansible. When Ansible connects to a host, it checks, among other things, how many cores it has, and then it sets a value for this variable. And in this case, we are deciding that InnoDB thread concurrency variable will be equal to the number of cores multiplied by 2. Okay. Don't focus on this particular example. I wanted to show that you can do this, and then the details are up to you and may depend on your specific use case. But this is not perfect, because there may be cases when Ansible is not able to find out how many CPU cores a machine has. So in this example, we try to find out this number ourselves. Okay, how? You can see that we run a shell command and we register the output into a variable called cores count. And then when we set a value for InnoDB thread concurrency, we try to use Ansible processor cores if it's set. If it's not set, we will use cores count. Here you can see how to handle differences between different microservices, because different microservices will probably have different requirements for the databases. For example, in most cases, we may want our databases to guarantee the highest possible level of reliability. Okay, so if we write something and we commit a transaction, generally we want those data changes to persist, even in case of a server crash. Generally. But there are cases when this is not necessary. For example, for microservices that work with something like, translations. Okay, maybe a translations microservice needs to be as performant as possible, and if this means that in case of a database crash we lose translations inserted in the last second, well, maybe it's totally fine. So you can see in this example we define InnoDB flash log at transaction commit equal 1 because it's the default. But then we check if a variable called consistency is defined, and if it is, and the value is relaxed, then we will write in the configuration file InnoDB flash log equal 2. Okay, so again, the second occurrence will override the first. So let's talk a bit about tasks and their conditionality and idempotency. So certain tasks should only be run for certain servers. For example, here you can see a task which sets read-only variable to 1. But we only want this to happen for replicas, certainly not for masters. So here we check if a variable called isReplica is set to true, or a value that is similar to true, like 1. And if it is, we run this task. But here is another example. The problem is sometimes we have many tasks that should be run if isReplica equals 1, right? So instead of repeating these conditions so many times and having a single playbook which is very, very long, we may prefer to use a separate playbook called replica.yml, and it contains tasks for the replicas, but it will only be included, so it will only be executed if isReplica is true. Let's go on, and let's talk a bit about idempotency. Most modules are idempotent, and you can see an example here. Maybe we have this task to start MariaDB. It uses a service module, and basically what it does is making sure that the service state is started. So if the service is not running, the task will start it. If the service is already running, the task will do nothing. Okay. And again, this is good because it means we can deploy this task multiple times, even in production. It will not restart anything. But there are cases when we do want to restart something. And so we have a very similar example when we use again service module, but the state is restarted. So even if the service is started, we restart it. Okay, it's not idempotent. The module will be started or restarted. In no case, nothing will happen. Okay, so there are modules that are actually written to be idempotent, but we can use them in a non-idempotent way. But then there are also modules that are very flexible, but they are not idempotent. And examples you can see here are shell, which runs shell commands on the system, and MySQL query, which runs SQL queries in MySQL or MariaDB. This is pretty logical, right? Because Ansible cannot understand shell commands, bash scripts, SQL queries, so it cannot check if there is a need to run them or not. It will just run them every time the task is executed. It's up to you to write proper scripts in a way that certain operations will not be repeated if not necessary. Okay, so again, these modules are probably the most flexible, but this means that taking care of what happens is totally up to you. And here you can see, well, as you probably know, Ansible supports tags, which should be defined properly, because here you can see multiple tasks have an install tag. So basically when we specify this tag, all these tasks will be executed, but then only one of them has tz info update tag. Why? Because normally, yes, when we install MariaDB, we may want to insert time zone information about system tables. But then when we want to update this information regularly, we don't want to reinstall MariaDB, right? So we should be able to run this task alone. And then you can see an example of how the tag can be specified when calling Ansible Playbook. Here you can see some typical tasks I want to have, but actually what I wanted to show here is that you can have tags for changing something in MariaDB configuration, but you will probably want to have two tags because there are two different cases. One is for updating variables that can be changed at runtime, and it's config dynamic update. And the other is for changing variables in the configuration file and then restarting MariaDB. Okay. Let's go on, and there is another case to consider because sometimes we don't want to run a certain task most of the times, okay, and maybe the task is dangerous, so it is much better that the task is not run by default. And the example here is a very common one, and it is well, no, actually it's not really shown in the example, but a common example is destroying MariaDB data directory. We don't want to do it on a production server, right? Because if we do it, we will destroy the current database. But sometimes we do want to do it. For example, if our database is corrupted or completely messed up, maybe we want to recreate it, and we need to destroy the data directory and recreate it. So Ansible doesn't offer something like, you know, an anti-tag. There is no way to say only run this task if this tag is defined. Okay, if no tag is defined in the Ansible Playbook command, well, all the tasks will be executed. So a solution is shown here. We are using the when attribute, and what we're doing is checking if a variable is defined and if it is set to true. Okay, only in that case the task is executed. This variable could actually be passed with the Ansible Playbook command, as you can see in the slide. Okay, so it can be an environment variable that we set with the -e parameter, which is quite standard because I seem to remember that the same parameters exist for Kubernetes and also Docker. So this was the last slide. So thank you very much for attending, and I will be looking forward for some discussions with you. Bye.